So a rhombus. What we know about a rhombus is the following. 4 sides are congruent. Oops, what the heck is that? 4 sides are congruent. You want to think about this as a square that's been squished. Sure, that works. It's a diamond in the rough. Okay? And so what we also know about this, what's special about a rhombus, is that the diagonals form a right angle. Yep, they will be note card worthy. We know that opposite angles are congruent. And we'll add up to what? Adjacent angles will add up to 180. All the angles will add up to 360. Okay. And we also know that the diagonals are congruent. Because the sides are congruent, the diagonals are going to be congruent also. I'm sorry, that's not right. That doesn't make sense. I'm thinking about a rectangle. That's not true. Sorry. The diagonals are congruent. That doesn't even make sense, right? If you're squishing this thing, doesn't one set have to be taller than or longer than another set of diagonals? Doesn't even look like they're the same, does it? Okay. And we know, let's see, we know that all the sides are congruent. And what's interesting in this case is that the angles are bisected by the diagonal. But the main thing that we're going to say about a rhombus is that the 4 sides are congruent. So if we know we have 4 sides are congruent, we can say we have a rhombus, if that's the only thing that we can say. Okay? All right, on a rectangle, we know that we have a rectangle. If it's a parallelogram, obviously these are all parallelograms, but if we have 4 congruent angles that equal 90 degrees. So if the only property that we state is that we have 4 right angles, we cannot say we have a square. We have to say that we have a rectangle. All right, so you have to be very specific. Okay, what else do we know about a rectangle? Well, what we also know about a rectangle is that the diagonals in this case are congruent. You know, the diagonals are congruent. We know that we have opposite sides are congruent. They are all parallel, yeah. Opposite sides in all of these are going to be parallel. I kind of didn't say it, but it is understood. And then in this case, because we've got right angles, the diagonals bisect the angles. So these 2 are the same. These 2 get bisected also. So this is one of the few where the diagonals bisect. Well, that doesn't make them 40. 45. Yes, yes. Mary? The diagonals bisect each other, and the diagonals are, well, I didn't say this. The diagonals are congruent, and the diagonals bisect each other also. I wasn't sure if they were going to have. Why don't you go to the library? Okay. Okay, but again, if the only thing we say is that we have 4 congruent angles that are 90 degrees, then we can define it only to be a rectangle. That's the only thing we can define it to be. Okay, square. If we want to define it to be a square, we have to say the following, that 4 congruent sides and 4 congruent angles. If we want to say a square, that's what we have to say. I'm sorry? Okay. But here are some other properties of a square. The diagonals, as in a rhombus, are perpendicular. The diagonals are perpendicular. And the diagonals are congruent. And the diagonals bisect each other. And the angles. All right, we know that all the sides are congruent. We know that all the angles are congruent also, correct? So a square is the most specific of our quadrilaterals or parallelograms. It has the most characteristics that define it. Uh-huh. Uh-huh. Yep, they are. Okay. So look at your chart. Take a look at the chart, this little chart thing that I said is going to be a really good friend of yours, this little chart. And let's talk about a rectangle. If we're going to define a rectangle, do we say that both pairs of opposite sides are parallel? Okay. Do we say that there's only one pair? Do we say that the diagonals are perpendicular? No. Are the diagonals congruent in a rectangle? Okay. Do the diagonals bisect each other? Yes. Sure. If they're congruent and you form a right angle, then they have to get bisected also, okay? Do we know that both pairs of opposite sides are congruent? Okay. Are all the sides congruent? No. Are both pairs of opposite angles congruent? Okay. Are all the angles congruent? Okay. Are the angles bisected by the diagonal? Not in a rectangle. Oh, I do said they are, but that is wrong. Oops. Diagonals. Oops. Hold on. Diagonals don't bisect the angles. Sorry. That was incorrect. They bisect each other. So I'm sorry, I had the wrong information there. So correct that in your notes, please. Okay. The sheet is your friend. It's basically what you want on each of your note cards. Okay? All right, what about a rhombus? What do we know about a rhombus? Do we have both pairs of opposite sides? Are parallel? Yes? Okay, what about one set of parallel sides? Are the diagonals perpendicular in a rhombus? Sure they are. See? I put a right angle here. Are the diagonals congruent? No, we changed that. Remember I started to say that, but then I said think about it. It's something that's squished, so the height is going to be longer than the length. Okay. Do the diagonals bisect each other, though? Okay. Are all sides congruent? Both pairs of opposite angles are congruent? Yes. Are all angles congruent? No. Are the angles bisected by the diagonal? Yes. Are all sides congruent in a rhombus? Are all sides congruent? Yes, because it's a square that's been squished. It's a square that's been pushed down. Something said on it. Mary, what's the problem? Okay, a rhombus, listen up so I don't have to keep repeating this. A rhombus has both pairs of opposite sides that are parallel. The diagonals are perpendicular. The diagonals bisect each other. The sides are all congruent. Both pairs of opposite angles are congruent. And the angles are bisected by the diagonal. Both pairs of opposite sides are congruent. Yes. No, all right, a square, last one we're going to talk about today. Most specific will have the most amount of check marks, yes? Which one are we not going to check on a square? What'd you say? We are not going to check that one. What's the other one? I mean, I guess you can check both pairs of opposite sides are congruent, but I also have all sides are congruent. So really, if you want, you can check all of them except for one pair of opposite sides are parallel. Okay? Because a square is the most specific of all of these. Are we good? Okay. Everybody with me now? We just have both pairs of opposite sides are parallel. We do not have perpendicular diagonals. Nope. Not today. Okay, so let's look. Remember, again, if I want to say I have a rhombus, I got to say I have four sides that are congruent. If I want to say I have a rectangle, I have to show that four congruent angles. A square, I need to say both four congruent angles and four congruent sides. So, a quadrilateral is a rhombus if and only if. What do we need to say? Four sides are congruent, yes. I have to say that if I want to say, could it be a square? Well, what else would I have to include then? And four angles, okay? A quad is a rectangle if, what do I want? Four congruent angles that equal 90 degrees. What do I need to say if I want to say I have a square? Four sides that are congruent, four angles that are congruent and equal 90 degrees, right? Now, we didn't really talk about this, but a parallelogram is a rhombus if the diagonals are perpendicular. So if I want to say, so this was, remember, these are for quadrilaterals, any four-sided. So if I start with the quadrilateral and I want to say it's a rectangle, I have to say that I have four congruent angles that measure 90 degrees. But if I want to say that I have a parallelogram and I want to say that it's a rhombus, then I need to show that I've got 90-degree angles occurring at the diagonals where they intersect. What would I use if I had coordinates? How would I show I've got diagonals that are perpendicular? Slope. I'd want to think about slope. Does that make sense? Like if 2/3 was the slope of one line, what would be the slope of the other diagonal? -3/2. No, but well, you might use them. Yeah, I'm not going to make you do it, but no. A parallelogram is a rhombus if in parallelogram the angles are bisected. Well, I can say two things about it. I can say either that the diagonals are perpendicular or that the angles are bisected by the diagonal. All right, and if we have a rectangle, then we have diagonals that are congruent and angles that are congruent. Two things from this case. All right, so this next problem is just going to be kind of an application of our properties that we got from this little chart. We're going to apply these properties to help us figure out all the information. Okay, I'm telling you we have a rhombus, a rectangle. B, D, E, G is a rectangle, and A, B, C, D is a rhombus. H is right here in the middle. Okay? We got a rhombus going on and a rectangle, so we have to think about what our properties of each of these are. Okay? So let's start by what was given. If 63 is given, what else can I find? This is about maybe before you can really answer your questions, you look at what's given in this chart and you just start filling in your information. Okay? So, what do we know that we can fill in? Kaylee, give me one piece of information. Where is that? BGC, and why do we know that? Alternate interior angles. But I told you we have a rectangle and a rhombus, so we do. Okay. What else can we tell from this? Give me one piece of information. Claire, yeah? And why do you know that? BD. Okay. So we know that this is a right angle, correct? Okay. So that means because we said that this was a rectangle, correct? And if this is a rectangle, this angle has to be 90, correct? And if this part's 63, then the top part is 27. Okay? What else can I do then? What do you see, Athena? Okay. Uh-huh. Angles B and E are 90. Okay, yes. We know that these are 90. We don't know how these are divided, but we know that these are 90. Uh-huh. Okay. Why do you know that? Okay. What else? Think. This is the problem you're going to see. Claire? B, E, and G, D are congruent. Okay, because they're diagonals in a rectangle. Let's find some more angle measures, though. Think of triangles. Uh-huh. Possibly. Why? You are correct. Okay. Okay, you are right, but we need to figure out why. Okay? So when you looked at that, what did you see? What kind of a figure did you see? Were you looking at the rectangle or the rhombus? Okay. Okay. Anybody know why this is supposed to be 27 degrees? No, I wouldn't see an exterior right angle. What do you think, Hannah? Why would you say HCD is 63? And so that left this to be 63. Okay, that works. So you made a little bitty triangle here, right? Uh-huh. Okay, hold on. Let's make this. Is this 53, isn't it? Okay. Okay. I'm sorry. Sydney, say again. BD and GE are parallel. Uh-huh. There's no theorem to show you movement. Okay, yes, Gabby? I still am trying to figure out why we know that this one's 27. Hold on. H, C, where's C? Oh, I erased it, sorry. H, this one? Okay. BE Look at your rhombus, guys. It has to do with why we have a rhombus. Talia? What do let's use what we learned. Let's use what we learned. We learned that this is a rhombus. Tell me about a rhombus. What do we know about a rhombus? Angles are bisected by the diagonals. So this is 27. What is this one? And what do we know about opposite angles? So therefore, this has to be 27 and this has to be 27. Did you follow that thought process? We have a rhombus, and we got to this fact that this was 27, which meant this was 54, which meant this had to be 54, which meant this was divided into 27 and 27. Isabel? For the same reason, right? If this is 63, what's this? Which makes both of these 63 also. Are you following my logic here? Again, we got a rhombus. So we went from a rectangle, and we took those angles and we moved into the rhombus shape. Okay? All right, let's see if we have everything that we need at this point. Okay? Find angle GDB. Well, what is it? 27 degrees. Angle ABC, 54. Angle DAB, 126 degrees. Angle BCG. Didn't figure that one out yet. Does it? Okay. How'd you get 54? Okay, you get 54, yes. Okay. So this one is, what is this, 50? 54? BCG? BCG, 54. What about GCE? GCE, 126. EDG, EDG. Oh, is it DEG? Okay, what's DEG? 90. Okay. What about AHB? 90 again. And DGB. There you go. Okay? So this is a big application problem. You'll see some of these again. All right, next problem. So if W, X, Y, Z. So W, start at a value, X, keep going around, don't skip. These need to be consecutive. Don't go W, X, and then put the Y down here and the Z here. That's not being either clockwise or counterclockwise. There's no skipping vertices. Does that make sense? So if WX is 1 minus 10x, and YZ is 14 plus 3x, then what is XY? And remember, this is a what? So we're using our properties. What would I do? We know all the sides are equal to each other. And so this is going to give me 13x is equal to negative 13. So x is equal to negative 1. Does that make sense? Is that okay to use? Why is negative 1 okay? It's a value, it's not a length. And if we insert it back into, do we get a positive length? Then that's okay. All right, what does that make our length? It makes like ZY is equal to 11. So then what is XY? Right, XY equals ZY because we're dealing with a square. Because we're dealing with a square. And what's the property of a square? All the sides are congruent. All right, here we go. Rhombus, W, X, y, z. If the measure of angle x is 24 times 10 minus x, and the measure of angle z is 6 times x plus 15, then what is the measure of angle y? Okay. What am I going to do in this case? Knowing that the property of a rhombus. Uh-huh. The marker's just kind of thick. Mary? Why? If this is not a side. Okay. In a rhombus, opposite angles are congruent, yes. So 6x plus 90 is equal to 240 minus 24x, yes? And so then I'm going to get 30x is equal to 150, so x is equal to, if x is 5, then angle x is equal to 24 times 5, which is 120 degrees, correct? What am I looking for? Well, how do I find y? If I know that this angle is 120, which makes this angle 120, how do I figure out what y is? Uh-huh. Can't we also just say that, what do we know about adjacent angles? So really, 120 plus x is equal to 180, so x is equal to 60. Sure, both ways works. I'm just giving you an alternate way. You know that they all add up to 360, but you also know, because it's a quadrilateral, that adjacent angles equal 180, which might make just the numbers a little bit easier. Okay, so let's look at the next one. Classify the special quads, explain your reason, and find the values of x and y. So we know that our options could be a what? 4 congruent sides, rhombus or a square. In each of these cases, though, what do we know? Okay, that allows me to say that 4x plus 17 is equal to 8x minus 3, yes? So 4x is equal to 20, which means x is equal to 5. Okay? In either case of a square or a rhombus, what do we know about the angles? And adjacents are 180. So let's see. What would make this a square? Would anything make it a square? No, because I got 108 degrees, right? So we're going to probably have what? So we know that 7y minus 5 plus 108 has to equal 180. 7y plus 103 equals 180. 7y is equal to, so y is equal to 11, which makes this angle 77 minus 5, which is 72 degrees. Therefore, we know we have a rhombus. Okay? All right, one more. I'm showing you, I believe, that just this part is 6x plus 21. Okay, I'm showing you right. What do I got here? Well, which one of the ones show the diagonals bisect each other? Not bisector, sorry, are perpendicular. Either a rhombus or a square. Most likely it's going to be a square. Square. Why do we know it's a square? All sides equal 3. Okay. Could I say it was a rectangle? You could. Sure. Couldn't you say a rectangle is a square? Is a square a rectangle? a square a rectangle? Isn't a square a rhombus? Isn't a square a parallelogram? Or can you go the other way? That you go from the most specific. The most specific is everything. The lesser specifics is not going to be the most specific. Okay? A square has everything.
So a square is everything else.
Everything. But everything else is not a square. This is going to be a square. This is, by the picture, this is very specifically a square. Because I'm showing you 90 degrees also. And so if I say, what are all my possibilities, then you would give me, well, it could be a square, it could be a rhombus, but if I'm saying, what is the most specific thing it could be, you would want to tell me it is specifically a square. Okay. All right? Do I need to do this one, or are you okay? Well, 6x plus 21. If this is a square, what do we know about both of these? So then, therefore, what does this equal? 45, right? Because a diagonal bisects a square. The angle's in a square. So that's why you got to look at the picture. Okay? That leaves you with 6x is equal to what? 20. So x is equal to... The y's are easy, correct? You just set the lengths equal to each other. 10y minus 29 is equal to 5y plus 16. 5y is going to equal... So y is equal to... Okay. All right. You may go